Okay, one moment. Okay. Thank you for joining today's webinar. Our topic is using permaculture to cultivate a sustainable security program. Our speaker today is Chris Nelson, who is Director of Security for Distill Networks. Chris is also the Vice President of the Denver chapter of the ISSA, and Chris is quite experienced with building several different types of security programs, implementing various security controls, and building those programs through maturity. Today, Chris is going to be talking about using the tenets of permaculture to build a sustainable and effective security program. So with no further ado, I'm going to turn it over to Chris. Chris, you want to take us away?
Thanks, Orion. Today we are going to talk about permaculture. We'll start with the basics, move into the 12 design principles, and then talk about how we can start implementing them with the concept of zones and some more detailed aspects of the design science. Permaculture, huh? What's nature got to do with security or technology? In this talk, we are using nature as an example, since the concepts depicted are generally universally understood without a significant amount of experience. I have tried to apply these concepts to generally known security, technology, or business examples. The goal here is for you to gain a basic understanding of permaculture so that you can apply some of these concepts and have a path you can continue to explore the benefits of permaculture on your own. At the end of this deck, there will be a couple additional resources for you to continue your journey. So let's dive into the basics of permaculture. So what is permaculture? Permaculture is a design science that mimics the systems within nature. While the origins of permaculture are in agriculture, the concepts have been applied to many aspects of design, including building communities and businesses. Permaculture is a harmonious integration based on a system of working with, rather than against, nature. Thoughtful observation rather than thoughtless action or reaction. Looking at systems and all their functions rather than asking only one yield of them, and allowing systems to demonstrate their own evolutions. So, where did permaculture come from? In the mid-70s, Bill Mollison and David Holmgren began to define the system. In 1978, Bill published Permaculture 1, and then in 1979, Permaculture 2. Today, the main text from Bill is Permaculture, a Designer's Manual. This book will be included on the additional reading slide at the end of this deck. Bill Mollison declared that the prime directive of permaculture is, the only ethical decision is to take responsibility for our own existence and that of our children. And the supporting concepts are life is cooperative rather than competitive. Life forms of very different qualities may interact beneficially with one another and with their physical environment. Cooperation, not competition, is the very basis of existing life systems and of future survival. The prime directive then feeds to the three ethics of permaculture. If you take nothing else from this talk, this would be it. If every decision you make is viewed through the lens of these three ethics, you are likely to see immediate and lasting improvements. The three ethics are care of the earth, or the system, care of people, and the third one is reinvest the surplus. As we look at these 12 design principles, think about what some of your larger challenges are. Is it a lack of resources, whether they be people, technology, or budget? Is it competing priorities? Changes within your governance, regulatory, and compliance space? Maybe it's training and awareness. Or designing, implementing, and enforcing policy and control standards. All of these are prime targets for applying permaculture principles, and I've highlighted some considerations throughout this talk. I have ordered these design principles in a somewhat logical order. Many of these are complementary and or companions to others. You'll see some overlap in the concepts, and it is important to note as that is intentional. Before making any actions, you should begin with observation. Our first principle is observe and interact. By taking the time to engage with the systems and the teams designing, developing, and managing them, we can ensure our solutions are appropriate for a situation and the organization as a whole. On day one in an organization or a project, observe the static and dynamic elements at play. Things such as current policy and control standards, legal and regulatory requirements, organizational structure, inter and intra-team interactions or procedures, state of vulnerabilities or defects, and other health indicators. The next principle is integrate rather than aggregate. By putting things in the right place, relationships developed between those things, and they work together to support each other. Eventually, this principle works for things like monitoring and quality assurance. There's a great opportunity for security teams to work with existing resources or to share the load on existing needs. For instance, there is little difference between, from a business perspective, a security defect or vulnerability and a functional defect. These tools might be different, but how organizations test, assess, assign, remediate is essentially the same. Expose privacy issues or other high-level concerns. The goal is not to get into the weeds here, but rather to highlight additional exposure as the organization is deciding to move forward with the objective. Security should be a consultant in this process and never say no, only highlight those risks. As we move down the process ladder and the objective becomes better defined into work, the security team's integration allows specific assignment of risk reduction or acceptance. Having security integrated into business and technology processes allows these relationships to build and informed decisions be made to better support the business goals and the final output of those goals. Here, we begin to move from observation into design, starting with designing from patterns to details. Here we can observe patterns in nature, society, and our systems and processes. These can form the backbone of our designs, with the details filled in as we go. Since complex systems that work tend to evolve from simple systems that work, finding the appropriate pattern for that design is more important than knowing all the details of the elements within the system. This is especially good when using a threat-centric approach. As you observe the threats and attacks against you, you can begin to shore up focus on the sources and targets of a threat and the current state of vulnerabilities. Highlight where those are. Then begin designing iteratively more detailed controls to address these. Using slow and small solutions allows you to observe the efficacy of your changes to your control environment, continuously building more specific solutions. Small and slow systems are easier to maintain than big ones, making better use of local resources and producing more sustainable outcomes. There's also a truth that investing less in a smaller or slower solution means you're less if that fails. You are failing, aren't you? If not, then you'll never succeed. Using permaculture in your system or program design allows you to accept feedback and self-regulate within your processes. This ensures a continuous improvement at levels than more traditional systems allow for. This concept can be seen in a similar format known as Agile, which is well documented to benefit not only your SDLC, but also managing your business through things like the Scaled Agile framework. Use edges and value the marginal. The interface between things is where the most interesting events take place. These are often the most valuable, diverse, and productive elements in the system. Think of the edge of a river. The usual abundance of growth there as it then fades up the banks and into the fields. The same is true between the pasture and the forest. These edges are extremely diverse and often produce tremendous yields. The margins contain value that may not be seen if you are foregoing your peripheral vision. For example, look at the intersection of traditional data centers and cloud computing. This is a great example of the edges. You can find tremendous value in these edges where the two ecosystems meet. Rapid deployment, increases in your compliance posture, lower capital expenses, All of these are some of the benefits of adopting cloud computing. But we should also ensure we adhere to the mantra, don't think you're on the right track just because it's a well-beaten path. And by now, cloud computing is a well-beaten path. Instead, focus on the principle that the problem is the solution. Apply the concepts and principles of permaculture, and you will likely yield greater business value, better recycling of surplus energy. Virtual or physical systems are one example of where you can find the surplus, but you can also realize surplus in operational capacity. In design, you want to make sure you are optimizing your resources. You can do that by using and valuing renewable resources and services. Make the best of abundance, reduce churn and wasted efforts. Monitoring is a great example of this. The same platform that operations uses for system monitoring and alerting can often be purposed for security monitoring specifically, and the operational metrics often provide supporting evidence during incident response. Another goal is to produce no waste by valuing and making use of all the resources that are available to us. How often do you waste time, money, and goodwill? Ever purchase software to only partially or maybe even never implement? Do you have a security team, a compliance team, a privacy team? How much overlap is there in the responsibilities? What about when the security team wants a centralized logging solution, but the compliance team comes along after the fact to implement a different solution because their requirements weren't included in the originals? Sometimes you have to balance this with using slow and small solutions, but the ultimate goal of that is to reduce the amount of waste. Considering both of these principles reduces the overall waste and allows you to adhere better to the three ethics. Catch and store energy. By developing systems that collect resources at peak abundance we can use in time of need. Don't wait until after an incident to collect information. System baseline information is extremely important. Excellent examples of this are file integrity monitoring or network heuristics using things like NetFlow. Ensure your audit and logging policy and procedures are generous and accurately implemented. On a softer, and perhaps more important note, as a security organization, you should contribute to other teams as much as possible, even when there is no direct benefit to you. This builds goodwill and stronger relationships with other teams. Oftentimes, security teams have subject matter experts with significant experience and tribal knowledge for moving throughout the organization. If you have that expertise, lend it to other teams when they need it. You will reap the rewards long into the future. Remember that all things can be turned into positive resources. Use and value diversity. Diversity reduces vulnerability to a variety of threats and takes advantage of the unique nature of the environment in which it resides. For instance, you can select different solutions in your solution layer. In this case, say you have a perimeter and internal firewalls from separate vendors. Separate vendors usually means different vulnerabilities. That allows a slight blue team advantage during the gap from identification to remediation of these vulnerabilities. This also complicates the environment for an adversary as they may not have the required knowledge of the solution's command set and thus cannot easily leverage these different pivot points within your environment. The inverse of this is that you now have to have teams that know and can support multiple solutions. Many employees see the ability to learn multiple solutions as only increasing their value and would welcome that opportunity. And this certainly follows the care of people ethic. Remember, this is a balancing act though. At the end of the day, you need to drive the business objectives as quickly, efficiently, and cost-effective as possible. The entire design science of permaculture is an effective way of ensuring that happens. Apply self-regulation and accept feedback. Discourage inappropriate activity to ensure the systems can continue to function well. Also, build in feedback loops to couple with this one with observe and interact. Initially focusing on the three ethics, reducing waste, building relationships, and appropriately tailoring policy and controls to your organization will help ensure that people do not feel the need to circumvent security controls. Let's face it, we either focus on tightening controls so much that effective business cannot happen, or we know that people circumvent controls that stifle the ability for them to do their jobs. Observing the environment before design and implementation reduces this. but so does implementing feedback loops to ensure that you are adjusting as you go along. Small and slow solutions help reduce the churn and respond faster to inefficient controls. At the end of the day, a tailored control is far superior to a bypassed one. Another essential principle is the ability to creatively use and respond to change. The goal is to have a positive impact on inevitable change through observation and then intervening at the right time. This also couples with feedback loops. Monitoring your processes, such as defects in your SDLC, and tracking those defects to the development teams that created them, allows you to know what vulnerabilities are being produced and helps you drive initiatives to reduce those defects closer to the source and thus costing the business less money. Does Team Alpha consistently commit code with SQL injection but never cross-site scripting? Then tailor additional SQL injection secure development training to them and don't subject them to unnecessary additional material. All your development teams undergo the OWASP fundamentals on an annual basis, but they shouldn't be subjected to unnecessary material that detracts from their regular duties. This helps engineers become better without causing ill will by subjecting them to boring sessions that are irrelevant to them. Other ways of using change include the adoption of platform as a service or infrastructure as a service solutions. These solutions do not remove your security and compliance responsibilities, but do make managing them easier, as it's now done through your vendor management process instead of having additional personnel to manage data centers, rack and stack servers, etc. While not for everyone, this option has helped make many organizations more secure, compliant, and focused on business objectives. Finally, obtain a yield. Are you getting true value out of your work? Let's start with the obvious. If you aren't obtaining a yield, where's the value to the business? Everything that is done should have a relationship to value for the organization. By getting past the macro level, make sure the smaller deliverables are tied to value. Where can you also apply that yield to other components? Things like configuration management utilize a concept called function stacking, where not only do they reduce time to deploy systems, those snowflake systems in the environment, and the accompanying management complexity, but they also can enforce control standards. If you manage the state of the system as a whole, as opposed to just the system, you obtain significant yield in both the operational and security domains. In Agile, it is a common practice to define the value for all work being done. This is usually done within the user story or work ticket, thus allowing everyone that reviews or performs the work to understand the value and the desired yield. So we've talked about the design principles, and they can be followed in an ad hoc manner and still drive value. But what if you're building a security program from scratch? Zones are a great concept within permaculture for breaking work into priorities. Zones start at the center, which is zone 0 or zone 1, depending on the material you're reading, and work outward as the amount of interaction required decreases. Zones up to 5, which is a natural system in the equivalent of wild or requiring no effort to produce and only minor activity for consumption. When designing, start at the lowest number first, get it under control, and then expand outward. This concept allows you to focus on immediate value, smaller solutions, and those items that you need on a more frequent basis. Zone 0 is the center from which we work. Permaculture principles are applied in terms of aiming to reduce energy and harnessing resources or creating a harmonious, sustainable environment in which to live and work. Zone 1 is a location for those elements in the system that require frequent attention or that need to be visited often. It also contains components that require continual observation, complex techniques, and in this zone, we arrange nature to serve our needs. Zone 2 includes elements which require frequent maintenance. Zone 3, your main artifacts go here. After they're established, they require minimal effort. Zone 4 is a semi-wilderness area, and Zone 5 is the wilderness area. There's no human intervention in Zone 5 apart from observation of natural ecosystems and cycles. Here's a quick application of some of these security concepts to how they might line up in zones. This assumes a well-tuned system for each of these items. So let's say you get about 25 to 50 IDS alerts per day. Your interaction with your malware solution about 10 times a week, either updating definitions or responding to alerts. So you review VPN or other access logs once per day, and you do one code commit and deployment per day. In this scenario, IDS would be in zone 1, your malware would be in zone 2, and your VPN and static code analysis would be in zone 3. For instance, static code analysis is usually run on code commit, or greater frequency like monthly, quarterly, etc. It is often filled with false positives that require a greater effort during those times of interaction, and for those reasons, it is in a higher numbered zone. Things like IDS alerts occur frequently throughout the day, take less interaction time usually, and hopefully, and are stronger value in the indicators of compromised world. These reasons put it into zone 1. You may perform multiple code commits per day, which may put this into a lower zone. These are just examples and not hard rules. Zones are a great way to begin the application of the design from patterns to details principle. Couple components that complement each other and look for opportunities for function stacking. For instance, your primary crop, let's say is squash, might be in zone 3 since once it's planted, you don't need to interact with it much until it harvests. You do have to worry about squash bugs, but you also want to maintain a natural system and not use pesticides. So you plant radishes, which repel squash bugs. You also get to harvest the radishes as a food product. This is an example of function stacking. We have already discussed how configuration management is an example of this in the technology world. There are additional concepts within permaculture design that couple or augment the 12 design principles. So let's talk about some of those concepts. The problem is the solution. This concept requires a mind shift for many people. There is a yin and a yang to everything in the system. How you approach it decides if it is a positive or a negative. For instance, in a garden, slugs are a well-known nightmare to the ecosystem and highlight an imbalance of the system. Sure, slugs are a problem, but if you add ducks to your system, the slugs become a resource as food for the ducks. Ducks also provide inputs into your system. If you have a leaky pond, the ducks' output will help to seal the pond. Ducks also make awesome eggs. In technology, there are other examples of this. Software developers continue to write insecure or vulnerable code. This converts to a training moment as soon as you start tracking who commits what defects and teaching those individuals or teams how to resolve and eventually avoid those defects. This is a more efficient method of secure development training than the spray and pray that most organizations practice. Just be careful of the application on this one. We've seen that the best way to fix a vulnerability is not to write a worm that infects systems and remediates that vulnerability. This, like many of these concepts, seems like common sense, and it is. Make the least change for the greatest possible effect. This is just a lens to look at your work through the Pareto principle or the 80-20 rule. One example is that 80% of your profits come from 20% of your customers. So focus on addressing the needs of those 20%. Or the 80% of your complaints come from 20% of your customers. In the security world, question, what is the source of 80% of your vulnerabilities? What can you do to address those things? For instance, removing admin rights on workstations immediately drops the percentage of malware infections. One action that has a large positive effect on your entire ecosystem. Chaos and disorder are detrimental to the stability of a system and for managing an effective security program. Synchronize your efforts. Focus on the right team for the job, utilizing efficiencies they already have in place and improve upon those. Look at the patterns to determine the details that are needed. For instance, development teams spin up AWS instances because they cannot get help from operations, but then take a hit on their throughput for writing code since they are now trying to manage systems. While doing this, they also introduce vulnerabilities into the environment, create an accounting problem, and ultimately create more chaos with business and technology processes when their output then needs to be incorporated back into the production environments. Perhaps a better solution is to embed operations team members in your development teams. The SDLC, or plan, build, run models, are examples of technology cycles. An agile SDLC promotes smaller deliverables focused on value. These cycles also make identification of security defects easier by being able to couple different tools to the different stages. For instance, you do static code analysis upon code commit, run dynamic analysis during your QA testing, manual code review as part of your accepting the story, and penetration testing at the delivery of the feature. Couple this with regular events such as pair programming on your day-to-day, monthly static code analysis across the platform, and quarterly penetration testing, and you have overlapping coverage cycles for your platform and increase the likelihood of identifying defects. Through the feedback loops within your SDLC, you can also determine where you need to apply additional training or where you need to develop or modify controls. When it comes to components within the system, your goal should be to balance diversity and capacity. The efficiency of the system is partially based on how well the components are integrated and how capable those components are at serving multiple functions. However, you need to focus on the positive connections between components, and you are more likely to have a stable, larger capacity system than if you are focusing on the individual components' capacity, stability, or yield. As you look at the elements within the system and their ability to function stack, remember that if we try to force too many work functions on an element, it collapses. Key elements may be people, processes, applications, or systems within the system. The concept of function stacking helps to ensure an efficient delivery of yield while reinvesting any surplus energy, but may collapse if too much is asked. Ultimately, we want to balance the complexity and the simplicity to ensure there is order and reduce the likelihood of an element's collapse. Remember that we are unlikely to ever understand all the connections an element has in a complex system, and that element may be making connections on its own. We can focus on the nature or value of these connections, though. This is definitely a concept that requires more study than this talk allows for, and I'd recommend a review of the materials posted later in this deck. This is also true when you're talking about people within the system. People like to be where their very different and complementary capabilities are used rather than being forced into a single function, or so many functions that they suffer deprivation or overload. This is a balancing act, but reminding yourself of the care of people ethic helps ensure every decision is made with this consideration in mind. If we throw nature out the window, she comes back in the door with a pitchfork. For instance, if we spray for pest infections, we end up also destroying the predators that feed on our pests. The following year, there's an explosion of pests because there are no predators to control them. In the security world, we know that if security doesn't fit with your users and environment, they will work around it. Ultimately, it is important to remember that we can assist rather than impede natural elements, forces, pressures, processes, agencies, and evolutions. In natural successions, grasses slowly give way to shrubs, which eventually give way to trees. We can use these progressions to provide microclimate, nutrients, and wind protections for what we want to establish. In security, we mimic this by ensuring we are building policy and controls that work within the flow of the organization and not against it. In chaos, you'd likely have underperforming systems and unhappy people. Fortunately, there's nowhere to go but up. Remember that our goal here is to harness the surplus of the entire system, or elements within the system, and redirect it to the basic needs of the entire system. We are not individual players, nor are there individual components that do not affect the whole. Collectively, we serve the goals of the system and ultimately the business. Since we are working on small solutions and iteratively improving, we must accept that we do not know everything about a system and that we will learn as time goes on. When we apply these principles from the start, we better set ourselves for the results we do not expect, and those results are more likely to be favorable. This is the classic feedback loop applied in steps. Stabilize a small area and develop a self-reliance for the elements within that area. Continue to observe and adapt through the process. Flexibility is the key here, as you have to acknowledge that you don't know everything going on, and that what you do know might change. The military concept of an OODA loop, observe, orient, decide, act, is a great way of depicting the stages of this cycle. As you stabilize one critical project, then you can look to expand to other projects. Some tips on getting going. Start the design on paper and start small, expanding outward using the zones concept. Know and understand the economic reality you are facing. You can only work with the constraints you have, but remember that the problem is the solution. Everything can be a positive, you just need to understand what you are dealing with. Trade for components. I have used marketing interns for data classification projects. Beg, borrow, and steal where you can. Just remember, relationships are everything, so don't do anything to jeopardize those. Deliver small, easily achieved units of value at a time. Ultimately, the success of any design comes down to how it is accepted and implemented by the people on the ground. Finally, as you begin putting it all together, remember that every design is an assembly of components. Your first priority should be to locate and cost those components. When you encounter scarcity, look closely at the resources you have around you and how they might be able to serve your needed function. Planning is critical, but don't let your plan get in the way of what you don't know. Account for that concept. Work in small solutions and iterate. For the early planning stages, it pays to collect evidence from everything: business process, teams, personalities, technology. Take into account the evolution in stages. Break up the job into easily achieved parts and place components that will be needed early in the development. These are some of the additional resources I had mentioned. There's the Permaculture Designer's Manual by Bill Mollison. David Holmgren has also written Permaculture, Principles and Pathways Beyond Sustainability. If you're interested in taking a Permaculture Designer's course, or PDC, you can take those online or in person, and the Permaculture Research Institute at permaculturenews.org is a great place to start. And then there's permies.com, which is an online forum full of awesome information. So that brings the permaculture section to a close. I hope you've enjoyed it and that you might be inspired to adopt some or all of the concepts into your own programs. Before I go, I'd like to let you know a little bit about Distill Networks. Distill started based on the realization that current protections were not adequate against certain threats, such as bots. Signature-based solutions like web application firewalls just cannot keep up with the dynamic threat that malicious bots pose. So, based on that concept, you need something more sophisticated. Here's how Distill works. As web traffic passes through Distill, we compare more than 40 criteria about each client request in real time. Based on this information, we create a fingerprint for each incoming connection and compare it to a known violators database. If this fingerprint is new, we then validate the browser to determine if it's a bot or not. Finally, based on your preference, we automatically tag, challenge, or block the bot. The value you get out of our solution is increasing insight and control over human, good bot, and malicious bot traffic. We can block 99.9% of malicious bots without impacting your legitimate users. This results in protection from web scrapers, unauthorized aggregators, and hackers, ultimately slashing the high tax that bots place on your systems and internal teams. Awesome, you say. I feel the same way. But don't just take my word for it. Jump on out to www.distillednetworks.com/trial and sign up for 2 months free to see for yourself. So with that, I'll pass it back over to Orion. Thank you all for attending. I hope you took some value out of this session.
Thanks, Chris. Thank you. That was a wonderful session. In fact, I know I learned an awful lot, and I'm sure our listeners did as well. For anyone who's listening, if you do have any questions, feel free to reach out to us at info@distillednetworks.com. You can also visit us at our website, distillednetworks.com, to learn more. And if you have any questions and want to talk to an actual human, feel free to call the number on the screen. Again, Chris, thanks for your time, and our viewers, thank you for joining us. Have a great day.